Hi everyone, just wanted to take a minute to talk about questions 9 and 10 from section 1-3, which you had requested I go over to help understand exactly what it is you're doing. So as I'm going through these, I just want to give you a little heads up. These questions might not be exactly the same as the ones you would have had. They might differ slightly by the numbers, but the concepts are the same. So whatever I do here, you should be able to apply to the questions that you specifically would have had. So if we're looking at this particular problem, we are told that two hikers are 33 miles apart. It's a pretty hefty distance. And here's my first hiker, and this first hiker is walking this direction, and they are walking at a rate of, I don't know, we're just told that they're walking at a rate. I'm going to make this purple person my slow person in terms of how their walking speed is, so they're going to be walking slower. And then my blue person here, they're going to be walking faster. So they're my faster walker, and they are going 4.4 miles per hour faster than the other person. So I don't know what the rate is, but I do know that it is 4.4 miles per hour more than whatever this person's rate is. So essentially, we are given a distance, we are given a rate, kind of, sort of, and a time. So this is a distance, rate, and time problem. So distance is equal to rate times time. The only difficulty here is we are told that they meet in 5 hours. So this person does end up walking for 5 hours, and this person walks for 5 hours. So the only problem with that is they're walking at different rates. This person's walking faster, so obviously in 5 hours, this person's covering more ground than this person. However, we know in total, they're walking 33 miles. So I don't know how much they each individually walked. We can figure it out once we have the rate. However, at this point, we just know that in total, they walk 33 miles after they've been walking for 5 hours each. So we know that this person, this purple person, they're walking for 5 hours at a rate of something. And this blue person, they are also walking for 5 hours, but now they are doing it at a rate of at a rate of this person's rate, but 4.4 miles per hour faster. And we know that at the end, they have walked 33 miles. All right, so they at the end have walked 33 miles. And that's a terrible 3, but that's okay, that's a 3. So when we do, now we can solve this, right? Because this is just a distance. This is a distance because rate times time is a distance. And that is equal to 33. So now we can solve this. So we have 5r plus 5 times r plus 5 times 4.4, I believe, is 22. And that is equal to 33. Okay, so when we combine these, we get 10r plus 22 is equal to 33. I subtract my 22. Now I get 10r is equal to 11. R then, once we divide by the 10, is equal to 1.1. And this is miles per hour. So we know that the purple person is going at a rate of r, which is 1.1 mile per hour. And so that means they're going at a rate of 1.1 plus 4.4, so 5.5. So now we can put that into our problem. So this would be, they're going at the slowest walker is going at a rate of 1.1. And for those of you that were in the class where I discovered and I put in the little keyboard, this is what it does. So this person, again, is going at a rate of 5.5. So you do need to be careful because it's not looking for the 4.4 or the 1.1 here. It's the 1.1 plus 4.4. Whoops. Okay, let's check our answer. Well done. All right, let's move on. So I'm going to erase this screen here. Okay, let's do blue because I believe we're dealing with a fisherman. We are. Okay, So fishermen can row upstream, so they're going up, and then downstream. So they're going up at a rate of 2 miles per hour. They're going down at a rate of 8 miles per hour. Hello? There we go. Of 8 miles per hour. He started rowing upstream until he got tired. Fair. And then he rowed downstream to his starting point. So we know that their distances for each of these are the same, right? So this distance is equal to this distance. I don't know what the distance is. It's just a distance that is the same for both. Now, how far did the fisherman row if the entire trip took 3 hours? Right? So we know that this one has a distance of d, and this one also has the same distance of d. So whenever I'm finally putting in my answers, whatever I solve for the distance going up is, I do have to be careful because it's looking for the total distance. So both the distance up and the distance back, which is the same. So you just have to essentially multiply whatever you get by 2. So you do need to be careful with it. All right, so we know at the end it took 3 hours. So again, we're giving a rate, we're giving a distance, well, we're kind of giving a distance, and we're giving a time. So we do know we are going to be dealing with distance equals rate times time. However, similar to the last problem where we were saying, well, add it together to make a total distance, we're going to do the same thing, but now we're going to do the same thing with time because we're told a total time. I don't know how much longer he was going up than he was coming back, right? Because obviously, if they're going the same distance, but this one's going slower, he's going to take longer to go the same distance, right? If I'm walking, it's going to take me longer to go somewhere than if I ran there, even if it was the same distance away. So my example is if I ran to go get coffee, I'd be there faster than if I walked to go get coffee. However, that wouldn't require me to run. So anyway, back to the question at hand. Essentially what we're doing here is we're going to be solving for our t, right? We're dealing with our time. So we have a time, and in the end, it took 3 hours. So we know in the end we took 3 hours. And his distance up, again, was the same as his distance back. So we know if he was going up and back, he was doing it at the same time, the same distance. However, his rates were different. So going up, he was going at a rate of 2 miles per hour. And then on his way back, he was going at a rate of 8 miles per hour. Now, essentially what we have here is our completed equation. We just have to now solve it. But just for reiteration, the reason we did this was because the distance divided by the rate is equal to the time, okay? And here, same thing. The distance divided by the rate is equal to the time. And in the end, we know how long it took. It took 3 hours. So we do need to clear the fractions. I mean, you could convert them into the same denominator and then add it, but I'm just going to clear the fractions. If I multiply everything by 8 times 8, I'm going to clear the fractions because this one will cancel with that one because, right, we have an 8 in the denominator. That's the same as having 1/8. So 8 times 1/8 essentially would just be 1. So we'll clear that. And then 8 divided by 2 would be 4. So I get 4d plus 1d is equal to 24. Add those together, I get 5d is equal to 24. And then my distance is going to be equal to 24 over 5, which, if I am correct, should be 4.8 miles. Now, he rode up 4 miles and he rode back 4.8 miles. I'm sorry, he rode up 4.8 and then down 4.8. So he didn't just do 4.8, he did it twice. So he did 4.8 times 2, which is 9.6. So we do need to be careful because it's not 4.8. I made that mistake the first time I did this problem and I wasn't paying attention. So it is 9.6 miles, okay? So we do need to be careful with that. So let's check our answer. Fantastic. That's great. So we just need to be careful, make sure that we are clear exactly what it is we are looking for, and we need to make sure that we set up our problem correctly based on the information that we have. All right, I hope that helps. Have a great day.